Welcome everyone. In this lesson, we will explore the first subunit under units and measurement, and that is measurement. Let's dive into how we measure things accurately in engineering and construction work. So, what exactly is measurement? It's simply an observation or estimation of the size or quantity of something, like the length of a table or the weight of a brick. But to measure properly, we need the right instruments. Depending on what you're measuring, you may use a ruler, a stopwatch, a thermometer, or even an ammeter. Every measurement has two key parts, the actual quantity and the margin of error. For example, a pencil might measure 10.2 plus or minus 0.1 centimeters. The 10.2 is the actual length, and plus or minus 0.1 is the uncertainty or tolerance of error. Let's go through the tools. To measure length, you might use a ruler, a measuring tape, or even a vernier caliper for better precision. To measure time, we use stopwatches and clocks. For temperature, we use different kinds of thermometers, including digital ones like those used in hospitals. Next up, mass and electric current. You measure mass using an electronic balance or a lever balance depending on the weight range. To measure current, tools like an ammeter or a digital multimeter are used, super useful for wiring or circuit testing. Now let's move to subunit 1.2, physical quantities. These are the real-world properties we can observe and measure, like how long, how heavy, how hot, or how fast something is. A physical quantity is any characteristic that can be measured. For example, length, mass, temperature, even electric current. Each quantity has a symbol and a unit. You'll see why this is important when we start doing calculations. Table 1.1 shows a physical quantities with the measuring instruments and symbols. Next, subunit 1.3. Let's break down measurements into two categories, base units and derived units. Base units are the basic building blocks of measurement. There are 5 you must know: length in meter, mass in kilogram, time in second, temperature in Kelvin, and electric current in ampere. These are universal and used in all scientific work around the world. Now for derived units. These are combinations of base units. For example, area equals length times width, measured in meters squared. Volume equals length times width times height, measured in meters cubed. Speed equals distance divided by time. Unit is meters per second. Acceleration equals distance divided by time squared. Unit is meters per second squared. See how powerful base units are? You can build complex ideas from simple measurements. In this subunit, you have learned that measurement is the process of determining the size, length, or amount of something using specific instruments. Each physical quantity like length, mass, time, temperature, or electric current has its own symbol and unit, classified as either base units or derived units. Accurate measurement is important in engineering to ensure precision, safety, and quality in every task or calculation.